In our previous video, we introduced the multiple regression equation and began looking at an example of multiple regression in which we were predicting grades based on school quality and how many hours a student studied. Now we'll go through the results for that analysis, focusing on three tables that provide the key information used to interpret our results. We'll also use basketball as an analogy to help us see what these tables are telling us. And as part of that, we'll focus on the Boston Celtics as a basketball team and Shaquille O'Neal as an individual player. And yes, I know Shaq retired years ago, but I like Shaq, and these are my videos. Okay, so let's get started. In SPSS, the first of these is what's called the ANOVA table. Now, it may seem odd that a multiple regression analysis will generate an ANOVA table, but as we'll see later, just like you could think of a t-test as a special case of ANOVA, you can think of ANOVA as a special case of multiple regression. So here's the ANOVA table generated by our multiple regression analysis. Notice that other than a few of the labels being different, it really does look just like what you would see if you ran an ANOVA. In regression, the F-test in our ANOVA table tests whether that set of all the variables in our model have a significant effect as a set. Can you reject the null based on the group of variables in our model? Using basketball as an analogy, the ANOVA table tells you whether the Celtics won. In this case, we see that our F-test with 2 and 397 degrees of freedom is equal to 15.648. Our p-value is less than 0.001. Notice the output says p is equal to 0.000, but do not make the mistake of reporting that p is equal to 0. This is just the software rounding a p-value that's less than 0.0005 down to 0.001. I'm sorry, 0.000. Always, always, always report this as a p is less than 0.001. I mean, it would have been nice had SPSS just included some code that recognized this and substituted 0.000 with a less than 0.001, but I didn't create the software. Now, sticking with basketball, you can see from this that our team of two variables won their contest against the null hypothesis. They were able to reject the null. Woo-hoo. Note that we only know that our team won. We don't know what the score was. We don't know if it was a squeaker or a complete blowout. From the statistical perspective, we know that we rejected the null hypothesis, but the ANOVA table doesn't tell us whether the effect was large or small. Maybe it was huge, or maybe it was relatively tiny, but statistically significant. Also, thinking of basketball, we know that the team won, but we have no idea how Shaq played. Did he have an awesome game or sit on the bench the whole night twiddling his giant thumbs? The ANOVA table tells us that the effect of the team was large enough that we could reject the null hypothesis, but it tells us nothing about the effect of individual players. It tells us nothing about our individual variables. Was this all due to how many hours students studied, or was it primarily due to the school quality or some combination of the two? We just don't know. Now, the second table in our regression output that we'll focus on is what in SPSS is called the model summary table. For now, we're only interested in the two highlighted cells here. In fact, you'll notice that I've hidden a few of the cells so that you don't get confused at this point. We'll look at those ones later on. Now, remember, in simple regression, The r squared was the proportion of the variance in the outcome that was related to our predictor. That's what the model summary tells us. How much of the variance in the outcome is being accounted for by our set of predictors. Here we see that our set of two variables has an r squared of 0.073. In other words, they account for 7.3% of the variance in grades. Notice it doesn't tell us if we rejected or failed to reject the null. It just gives the r squared value. If I want to see whether the r squared of 0.073 was large enough to reject the null, I need to look at the ANOVA table. Now this is important. The f-test in the ANOVA table is the statistical test for this r squared value. They go hand in hand. Together, the model summary table and the ANOVA table would let us report that our r squared of 0.073 is statistically significant with an f of 2 and 397 degrees of freedom equal to 15.648 with a p-value less than 0.001. Also, notice that still none of this tells us about the contribution of the individual variables. Statistically, we know how large the overall effect was that we obtained, and we know that we rejected the null hypothesis. But we don't have any idea of whether this was largely due to one variable or the other variable or both of our variables. Returning to basketball, the model summary table answers that question of what was the final score for the Celtics? Did the team score 80 points or 120? The model summary table tells us what the score was, how big the effect was for the team, but it doesn't tell us if the Celtics won or lost. It just gives us the score. And in this case, you can think of it as the team scoring 7.3% of the variance. We know the score, but the model summary table doesn't tell us if the team won. Again, we need to go back to the ANOVA table and look at the f-test. That's the test for this effect. Also, we still don't know how well Shaq played. We know the score, we know the team won based on the significant F in the ANOVA table, but we don't have a clue about individual players' performance. Maybe Shaq carried the team to victory, or maybe he barely played at all. We need the equivalent of one of those individual player statistics tables that you may see in a sports section of a newspaper. But where do we get that? In regression analyses, we see that in the coefficients table. The coefficients table provides the individual results for each of the predictor variables in the regression model. This includes their effect, both the unstandardized and the standardized regression coefficients, and a t-test for those effects. Now, you have to pay attention here because SPSS uses a capital B for the unstandardized regression coefficients, not a lowercase b. Also, for the standardized coefficient, SPSS simply spells out the word beta instead of drawing the fancy Greek letter beta. And finally, instead of using the term intercept, SPSS refers to the intercept, our B0, right, as the constant. Now in practice, you'll see B's and betas used interchangeably at times. Some will refer to the unstandardized coefficient as the unstandardized beta. You may see the beta used for the unstandardized coefficient, or as we see here, a capital B used. The key is to recognize whether someone is referring to the unstandardized or the standardized coefficient, and make sure you interpret it appropriately. Now for clarity, when I'm teaching, I'm going to use lowercase b's for the unstandardized coefficients and betas for the standardized coefficients. Also, that label constant may seem like an odd choice of a word to describe the intercept, but there's actually a beautiful and very solid mathematical basis for this. If you're interested, be able to see that later on. Now, returning to our basketball analogy, the coefficients table is where you get your individual player stats. This is where we see, how did Shaq do? Did he have a large impact on the results? In other words, how large was the regression coefficient? Which players had a significant effect on the outcome? Which players had significant t-tests? Now, I've taught regression a lot, and more than a few students over the years have commented that this analogy helps them keep track of what information is being reported in which part of our regression output. So this won't be the last time we talk about basketball and Shaquille O'Neal. So remember, the ANOVA table provides the statistical test for that total overall regression model with all of the variables in it. But it doesn't tell you how large the effect was or whether any individual variables were significant or not. The model summary table tells you the R-squared, how much of the variance in that outcome was accounted for by our predictors. But it doesn't tell you whether the variance was statistically significant. The F-test in the ANOVA table answers that question. And you'll often see those two pieces of information reported together. The coefficients table is where you get the individual statistics for each of your predictor variables. What's their regression coefficient? Is it statistically significant? Okay. Now, with that behind us, let's wrap up this video. In our next video, we'll take a closer look at R and R-squared and the F-test that we use to test our R-squared. Okay, bye for now.